All right, let's look at these questions together. In question 1, if this was an equation, you would simplify on both sides. Here I would use the distributive property, and on the right, I would gather like terms. So we have 8 plus 8 minus 4x is greater than negative 2x. I can also combine like terms on the left side now. I'm always going to be looking to see if you simplified, because that idea of simplifying before you move on is really important. As questions become more and more complicated, you want to be working with the simplest version of your question. Now, it doesn't really matter if we leave x on the left or the right, so let's look at it both ways. For A, let's add 4x to both sides. I know some of you learned just to move the 4x and change the sign, but what we're really doing is the same thing to both sides of the equation. This is going to become important when we're working with exponential equations, logarithmic equations, trig equations. We always do the same thing to both sides. I don't care if you don't write this, but I want you to know that that's what's happening. So we're adding 4x to both sides. 16 is greater than 2x. Now we can divide by 2. And we see that 16 is greater than x. Let's look at B. This time I'm going to keep x on the left side of the equation. So I'm going to add 2x to both sides, but I'm also going to subtract 16 from both sides. So we have negative 2x is greater than negative 16. Now I'm dividing by negative 2. Remember what happens when we divide by a negative number. The sign has to change directions. X is less than 8. Oh, I didn't write my 8 over here. You guys weren't loud enough and didn't tell me 16 divided by 2 is, of course, 8. When I make a mistake, please let me know. It happens. I want you to pay close attention to these two statements. One of them says 8 is greater than x. The other says x is less than 8. But in each of them, the small side of the sign is pointing to x. They say the same thing. In fact, we usually like to write our variable on the left side. So if I turn this sign around and put x on the left and 8 on the right, I have to turn the sign with it. The nice thing about having x on the left side is it tells me which direction to shade, because I wanted you to put your answer on a number line. We can see that x is less than 8, heading towards negative infinity. Not equal, so remember when it's not equal, we use an open or round bracket. I also wanted you to write your answer in interval notation. Interval notation uses the endpoints. So we have negative infinity to 8. We always use a round bracket on negative infinity, and x is not equal to 8. So we use a round bracket there. I see that I also want that answer in set notation. So let's go back and look at question 1. Set notation for all numbers of x such that x is less than 8. Sometimes we add that x is an element of the real numbers. I don't think that Pearson requires that. I think if you just write x is less than 8, that would be sufficient. All right, let's look at question 2. This question has x in the middle of 2 fractions. I would say the first thing we want to do here is get rid of the fractions. So we're going to multiply all parts of the equation by the lowest common multiple of the denominator. What is the lowest common multiple of 6, 3, and 9? I hope you know this. It's 18. So we're going to multiply 18 by 1/6, 18 by everything in the middle, and 18 by 2/9. When we do this, we can get rid of the fractions. And that is, of course, very good. 18 divided by 6 is 3. 18 divided by 3 is 6. 18 divided by 9 is 2. And 2 times 2 is 4. We can use the distributive property inside. And now we just want to isolate x in the middle. So the first thing we're going to do is subtract 18. Remember, when we subtract 18, the signs don't change. And in fact, if I look at that negative 15 and negative 14, negative 15 is less than negative 14. It is to the right, or sorry, to the left on the number line. But now we want to divide by negative 12. When we divide by a negative sign, negative number, the signs change direction. A negative divided by a negative is, of course, positive, but we can reduce this fraction. 15 over 12, divide by 3, divide by 3. 14 over 12, we can divide each of those by 2. I hope you can recognize that 7/6 is less than 5/4. So we would actually want to turn that whole statement around. We would want to write it as, oh, I don't know what happened there. One moment. We would want to turn the whole thing around and say that 7/6 is less than or equal to x, which is less than 5/4. On our number line then, x is all of the values between 7/6 and 5/4. We're going to include 7/6. We see that x is equal to, so we're going to have a square bracket there, but not equal to 5/4, an open bracket there. So when we write our answer in interval notation, we have our end points with a closed or square bracket on 7/6 and a round or open bracket on 5/4. When we're writing this in set notation, for all the values of x, such that x is greater than or equal to 7/6, but less than 5/4. Again, this is a good time to go to the homework in Pearson and do some practice.